Okay. So like I said, we're looking at day 2. You're going to be able to solve absolute value equations and inequalities more in-depthly. So an absolute value equation we looked at on Friday was just being able to simplify them, understand and know what it meant to simplify an absolute value, and the representation of what an absolute value was. So an absolute value is the distance a number is from 0 on a number line. Today, we're going to solve absolute values. When solving absolute values, an absolute value has 2 distances from 0. It has its positive and negative distance. So we have 3 steps we're going to follow in order to solve an absolute value equation. The first thing we need to do is to isolate it, then rewrite it, and then solve. In those first 2 examples, the absolute value is already isolated. So our next step is to rewrite it as 2 equations. So what we're going to do is split the absolute value into the positive and negative. So the positive is taking it exactly as it is. And then to the negative, you're going to take 15 minus 3x and set it equal to negative 6 as well. So we're going to set the absolute value equal to the positive and negative right side of the equal sign. And then you're going to solve for x in each. So we're going to subtract 15. Divide by negative 3. And we get x equals 3. Divide by negative 3. And you get x equals 7. So you'll see that these answers aren't opposites of each other. Next, you need to check. So we talked about something called an extraneous solution. It's a solution you get when you solve the equation, but when you plug it back in, it does not work. So we're going to do a quick check by plugging these back in. So you get absolute value of 15 minus 3 times 3. And we want to make sure that equals 6. So 3 times 3 is 9. 15 minus 9 is 6. Absolute value of 6 is 6. So 3 checks out. We're going to do the same thing with 7. 3 times 7 is 21. 15 minus 21 is negative 6. But you don't take the absolute value. They act like grouping symbols, so you don't take it till you simplify the inside. So the absolute value of negative 6 is 6. So 7 also checks. Okay, number 2. Step 1, isolate the absolute value. That's done. Step 2, split the absolute value into the positive and negative. So that's 3x plus 2 equals 7. And 3x plus 2 equals negative 7. Solve for x. So we get x equals 5/3 and x equals -3. And then we need to take each of those and check them. So 3 times 5/3 is 5. 5 plus 2 is 7. Absolute value of 7 equals 7. So that checks. Absolute value of -9 plus 2. Well, -9 plus 2 is -7. Absolute value of -7 is 7. So -3 also checks. If you have one of the graphing calculators and you're trying to work or solve these on them, the absolute value is found under the word math, an arrow to num, and it's the ABS. So if you have the graphing calculator, you hit math, which is the third button down, arrow 1 to the right to num, and you do ABS. So you could hit the ABS and then type in that -9 plus 2. It'll do the math in there for you. Okay, so in number 3, the absolute value is not isolated. Therefore, you have to solve for the absolute value. So the first thing we have to do is subtract 4. Divide by -2. So you get the absolute value of x plus 9 equals 4.5. You could also leave it as 9/2 as a fraction. That's fine also. Now that the absolute value is isolated, we split it into 2 pieces, the positive and the negative. Subtract 9 from both sides. And we get x equals -4.5 and x equals -13.5. The last thing we need to do is to check. And you can check anywhere you want, but I always suggest checking with the original problem. So -4.5 plus 9 is 4.5. Two times 4.5 is -9. So 4 minus 5 is in fact -5, or 4 minus 9 is in fact -5. So that checks out. Absolute value gives you positive, and then you get 4 minus 9, which is equal to that -5. So -13.5 checks out. I promise you they don't always all work. We're just working on solving right now. Okay, number 4. Once again, you need to isolate the absolute value by getting rid of the 5 and the 2. So we're going to subtract 5 from both sides. Divide by 2. So again, you cannot split the problem until it's isolated. solve for your variable like we did in solving equations. And check. Three times 5, 15. 15 minus 1 is 14. 14 times 2 is 28 plus 5 is 33. Three times negative 13 thirds becomes negative 13. Negative 13 minus 1 is negative 14. Absolute value of negative 14 is 14. 2 times 14 is 28. 28 plus 5 is 33. So these problems are now different. You don't just have your absolute value equal to a number. Your absolute value is now equal to an expression. So we get 3x minus 4 equals negative 4x minus 1. And 3x minus 4 is equal to 4x plus 1. Because it is the negative of that side. Well, since that side was both already negative, they both became positive. So you keep it exactly as it is, and then you multiply everything by negative 1. Solving for x. You get x equals 3/7 and x equals negative 5. We're going to check them. So we get 9/7 minus 4, which is negative 19 over 7. But the absolute value makes that positive 19 over 7. Over here, negative 12 over 7 minus 1 is negative 19 over 7. However, there's no absolute value, so you get positive 19 over 7 equals negative 19 over 7. Does a positive 19 over 7 equal a negative 19 over 7? The answer is no. So this fails the check, meaning it's one of those extraneous solutions. So it does not get the check mark. It fails. So you put the X and you have to label it as an EXT solution. I'm not going to make you write out extraneous, but that's what it is. Plugging in negative 5. we get 19 equals 19. So just because one fails doesn't mean the other fails. One failing does not imply the other fails. So -5 works, but 3/7 does not. Okay, let's look at the other example. You have 2x plus 3 equals 3x plus 2. So we're going to split our problem into the positive and the negative. So again, everything on the other side becomes negative. So the opposite of 3x is -3x. The opposite of 2 is -2. Solve for x. So hopefully when you solved, you were able to also get 1 and -1. And then you need to check them. So 1 works because you get 2 times 1 plus 3 equals 3 times 1 plus 2. Checking -1. You get 1 equals -1. Since 1 does not equal -1, -1 fails and is an extraneous solution. Okay, and number 7, we have absolute value of x equals x minus 2. So splitting, you get x. You have x minus 1. Okay. That's about as good as I can get. So you get x equals x minus 1 and x equals -x plus 1. So subtract x to this side. X minus x is 0 equal -1. Does 0 equal -1? No, so that didn't even give me any answers. That was just totally bad. Over here, you add your x, and I get 2x equals 1. Divide by 2, so we get x equals 1/2. Plugging that in, you get 1/2 equals 1/2 minus 1. So you get 1/2 equals -1/2. Does a positive equal a negative? No. So this part also fails. So you get an extraneous solution and a no solution. So there are no real numbers that work. So there are no values for x that work for this equation. No matter what you plug in, it will not work. So this is the empty set or no solution. Your favorite, it's word problems. So we have a tennis racket that has 100 square inch head, and it can be varied by plus or minus 20 square inches. So what that means is the range could actually between 80 and 120, right? So if it can change 100 to plus 20 or minus 20, then I know that the range is 80 to 120. Write and solve an absolute value equation to determine the least and greatest possible sizes for the head of an adult tennis racket. So this is kind of like our answer. I need to know how to get that answer. So I know that it's going to be 100. And you could do minus x has to be less than or equal to 20. That way, if you plug in a number for x like 120, 100 minus 120 would be negative 20. Absolute value would still be equal to 20 or smaller. So again, you could check by plugging those in and seeing that they work. Okay, your homework is the next 10 problems on the next 2 pages. It is spaced out. I remind you to check.